Welcome everyone. Good morning, or good afternoon rather, to those on the East Coast. Good morning to those on the West Coast. This is part 2 of a series of webinars, and the name of this one is Tall Mass Timber Construction for the 2021 International Building Code, Part 2, Heights and Areas and Construction Fire Safety. And I'm glad you're with us. It's a new topic to everyone, relatively new, although we've already been teaching and have many webinars on this topic on our website. We will be covering these two topics in particular today, but I will also be giving some background information about the topic of heights and areas and how the new construction types for mass timber came about and how the heights and areas came about. And the second part of the program will be presented by Ray Obraki, and we're very fortunate to have Ray on AWC staff. He will introduce himself and give his background. My own background is that I began many years ago as a building inspector in the city of Indianapolis. I went from there to plan review for the state of Indiana, and then I pursued consulting and engineering, and did a little engineering, and ultimately wound up on the code development staff of BOCA International, Building Officials and Code Administrators International, at the time that it was transitioning into the International Code Council, along with the two other regional legacy code official organizations, and worked on the code development staff there, and that's where I really became immersed in the building codes, and then went to AWC, first in the Midwest, now in the Southeast, and still get many opportunities not only to teach about wood in the building codes and provisions for wood, also of course our design standards. We're an ANSI accredited standards writing organization, and the NDS, the Wood Frame Construction Manual, the special design provisions for wind and seismic. Many of you who are designers are familiar with those. They're referenced in the building code. Once again, we have many courses on those available for you to take individually and take a test and get credit all on your own. Marcy went through this. These are copyrighted materials. And a little bit about this course in particular. You've already read the description, I'm sure, but this photo here is of the Brock Commons student housing at a university in Vancouver, Canada. It's still, I believe, though not for long, the tallest mass timber structure in North America, and it is made of mass timber. So the topic, of course, is heights and areas. This is a tall one, 18 stories above grade, 17 stories of mass timber on 1 story of type 1 podium concrete construction. And of course, the new thing here is this is wood construction. There are some non-combustible cores to this building. You can see them on the left there. See if I can get my, my spotlight going here. So this is part of the core, the exit shaft, elevator shaft also in the building. And the rest of it is mass timber, cross-laminated timber, glue lam, and also, of course, non-combustible materials. I'll mention that though we're talking, the feature of this is all the tall mass timber. That the other webinars, the introductory webinars to this series do cover the mass timber products and how they can be used in low-rise as well as high-rise buildings. But today we'll discuss the development process, and really you'll get a sense of the thinking all around the topic of going higher for wood construction and why. A couple other just random topics kind of as part, it was impossible to list all the individual topics, but fire barrier requirements, construction site fire prevention. This is really a separate topic, and it's kind of unusual that we combine these two topics, but they do go together well, because there are some specific provisions for taller wood during construction, and then the owner responsibilities that has to do with the fire code and building maintenance. So here's the series that we've been offering. This is part 2 of the second half of the major series, which is focused on the new construction types for tall mass timber. So these two focus on what is mass timber, what are the products. The second one is available on our website. You can find out what adjustments were made to the code that have to do with heavy timber that are necessary background for really plugging into the brand new construction types. And when I say construction types, I'm never quite sure how familiar everyone is with the code. Sometimes we have people that are pretty unfamiliar with the code on the webinars, but you have traditionally types 1 and 2, non-combustible. Those are your highly fire resistant, taller buildings, high rises and so forth. And traditionally wood is in the mid-rise to low-rise range in types 3, 4, and 5 construction. Well, what's happened is 3 new construction types were introduced into type 4, and they can be high-rise buildings. So we're here kind of at a culmination of much of the discussion. And let's try a poll question. Marcy will lead us through this. This has no right answer, of course. Later on, we're going to do these to see if you're listening to me. So get used to weighing in with your vote here. Thank you.
Yep, it's always interesting too to see the makeup of the audience. So I usually wait for about 30 seconds or until about 80% have voted. And it looks like I'm going to have both. So here we go. All right, so 49% engineer, 32% code official, 7% architect and fire service, and then 4% other. So no matter your profession, we are delighted that you are here and hope that you find something of value.
Great. Nice spread. Glad we have a good showing with code officials and engineers. And we were discussing a little bit beforehand, the topic of heights and areas might be pretty boring to architects. They do it routinely, but this really goes beyond that. And I hope you'll find it interesting and useful. So mass timber is not conventional frame construction. And it is new. It is very new. And if you're skeptical about that at all, and you're, maybe perhaps skeptical about the increased heights and so forth, let me just start by saying everything you see here is not permitted over here. You're seeing studs, you're seeing joists, you're seeing repetitive member assemblies. Light frame wood assemblies are not permitted as floors, walls, or roofs in this construction type. They have to be actually solid timber walls, floors, and roofs, if it is a wall, floor, or roof, or heavy timber columns and so forth. So we'll see that this is a new ball game, and this is the reason behind the new construction types. This, by the way, is the Brock Commons building that I showed in the first slide that's under construction. Also, mass timber now on the right side here is different than traditional heavy timber construction, type 4, what is now called type 4 HT. And some of the differences here, primarily for mass timber compared to traditional heavy timber, is the fire resistance. It's very highly fire resistant compared to traditional heavy timber. And there's other features that are required for the building overall. And I'm going to make a big deal out of this topic of non-combustible protection, because not only are light frame wood assemblies not permitted, but they have to be mass timber or non-combustible in a mass timber in the new construction types. Not only that, but we're going to see there's a new concept, and you've heard about it in other webinars already, but it's the concept of required non-combustible protection on mass timber surfaces. So then we'll discuss heights and areas, construction fire safety, and among those, owner's responsibility having to do with the existing building when it's done. There are a couple new definitions in the 2021 IBC. And by the way, this is available in PDF form right now from IBC. You can purchase this and you'll get the PDF right away. The printed book is not quite available yet. And I'll mention right now, we didn't really mention it in the morning session of this same webinar, and I should have, but this document down here, Mass Timber Buildings and the IBC, produced by the International Code Council and the American Wood Council together, is also available. This is available in print and PDF. You can order this right now. It will go into it does go into detail and illustrations on all the requirements of the new 2021 for tall mass timber that we're discussing today. So it's a great resource. I highly recommend it. It's the significant changes book among that series for ICC, which are so popular. Well worth getting. I think it's $40 or something. Okay, so in the code, mass timber defined, and really the essential part of this definition is that at a minimum, mass timber elements have to meet the minimum cross-section dimensions for type 4 that are in that table in chapter 23 now of the 2021 IBC. They're typically panelized, especially when we get to cross-laminated timber. They're panelized, they become solid timber walls, floors, and roofs rather than repetitive member walls, floors, and roofs. But another significant definition is for non-combustible protection for mass timber. So certainly non-combustible is defined by the code requirements already. We're all familiar with that. But the concept of non-combustible protection is going to have a lot of code provisions talking about that. What is it? How is it determined? How is its fire resistance determined? So the definition here, a material in accordance with 703.5, and I believe this is going to be after correlation of the new code, which has taken quite a while. I believe that's going to be 703.6. And it talks about the contribution of how to determine the fire resistance contribution of the non-combustible protection. So it has its own definition. The new construction types are 4A, 4B, 4C, and the existing heavy timber provisions in the code, unchanged by the Tallwood Ad Hoc Committee of ICC, which was the primary researcher and author of the tall mass timber provisions in the new code. And then it went before the entire, International Code Council membership, and they had to vote on these. But the significant work of research and testing and drafting of the provisions was the work of the ICC Ad Hoc Committee on Tallwood Buildings, a broad-based committee that included all representation from regulators, code officials, fire officials, fire protection engineers, designers, certainly, structural engineers, architects, fire experts, and they did the work. And if you have not seen our webinars on their work and on their testing, they're well worth looking up. You can see the full-scale testing that I'll talk about a little bit later on our website. They did not change the regular heavy timber requirements. Their proposed code changes, their approved code changes, 17 in all, very comprehensive, some of them long code changes, did not change the regular heavy timber requirements in the code. However, there are some changes to the regular heavy timber provisions in the 2021 by other sources that entered code changes into the code that were successful. Maybe I'll mention a few of those later. Okay, I hope this will give you some context perhaps for the differences between the new construction types in regard to that non-combustible protection or materials requirements. And this, I know that some of these concepts for the new construction types are hard to get our heads around because they are new to the code. We haven't really seen anything quite like it yet. And particularly the principle of adding non-combustible protection to the calculated fire resistance of heavy timber. But this may help us with some context. First of all, there is no exposed mass timber surfaces in Type 4A construction. And Type 4A allows the greatest heights of the three construction types and the greatest areas. There is limited exposed mass timber permitted in Type B. It says 100% non-combustible protection on all surfaces, except limited exposed mass timber elements. It will be around the range of 20% of the floor area for the ceiling, 20%, 40% of the floor area for the walls. We'll see that. So limited areas, not half, not even a quarter in some cases in case of the ceilings, but some. And then Type 4C, all the interior areas, they do not require non-combustible protection on the mass timber. It can all be exposed, except that's not true completely either, because some critical features in the building still need the non-combustible protection, such as shaft walls and concealed spaces. If there's mass timber in concealed spaces, that has to be protected. Materials, MT is mass timber, NC is non-combustible, boom. All three construction types, that's all that's permitted. The primary structural frame, load-bearing walls, non-load-bearing walls. None of these new construction types permit wood frame that's not mass timber. They do permit non-combustible frame, like steel frame. That would be within the non-combustible category. Certainly concrete and masonry as well. And then on the topic of shaft and exit enclosures, typically the focus here is a key life safety feature for the performance of the whole building. So in Type 4A, Type 4A is the only one of these three construction types that can go above 12 stories and 180 feet for any occupancy. So over here you have not permitted, not permitted. It's just not applicable. These buildings don't go that high. But above 12 stories and 180 feet, the shaft and exit enclosures have to be non-combustible. Okay, and they can be mass timber if they're up to 12 stories, not beyond. But the mass timber is heavily protected with non-combustible material. Same with Type 4B. The ratings are a little bit less, but the protection is basically the same, slightly less in the case of 3-hour elements. And then in Type 4C, the shafts and exits can be mass timber. They can also be non-combustible, of course, but the mass timber is protected with one layer or 40 minutes, we'll see, of gypsum. And they still have to be required to be rated for the full time, typically a 2-hour rating for shafts. So here's the new deal. Gone into great detail in some of our other webinars, but this principle here about the 2/3 of the fire resistance rating being achieved by the non-combustible protection on the mass timber. That's a new principle for the three new construction types. It does not apply to any other of the existing construction types. So what does that mean? It means you have a floor that's 2 hours. The whole floor has to be rated for 2 hours, and the bottom of the floor has to be protected with at least 2/3 of the 2-hour rating, which is 80 minutes. So while the whole floor together with the non-combustible protection has to achieve 2 hours, there's a minimum requirement for how much of that has to be met by the non-combustible protection. And that's the new way of thinking That does not apply to other construction types. No exposed mass timber in type 4A and type 4B. The same principle up here for type 4B, but you can have some exposed, and those elements that are exposed still have to meet the full fire resistance rating by calculation for an exposed element. So typically on the parts that cannot be exposed, which is most of the surfaces, typically you'll have some overkill on the fire resistance ratings because they'll go ahead and add the required 80 minutes, for instance, for a 2-hour, 2/3 of 2 hours, and there'll be that much more fire resistance. And then type 4C, no particular requirement for that 2/3 has to be achieved by the non-combustible protection, except certain features are still required to be protected. As I mentioned, shafts, concealed spaces are the primary ones. All right, a poll question. So I'll turn this over to Marcy and see if you can have caught what I've said about type 5A construction.
Sure. So is it type 5A or type 4A?
I'm sorry, 4A. And you know what? I may have done that to you in the morning session too.
So type 4A construction, what fraction of the required fire resistance rating must be provided by non-combustible protection? Is it 1/3, 1/2, 2/3, or variable depending on the building height? All right, I've got about 70% and 45 seconds, so I'm going to close and then share. So 67% say 2/3, 25% variable depending on the building height. Paul, what say you?
I say 2/3. So let me advance the slide to highlight so 4A construction, and it always, when it's required to be fire resistance rated, it always requires 2/3 to be, no matter what the height of the building, if it's required to be 4A, 2/3 of it has to be achieved by the non-combustible protection. This was a tricky throw off there. There's other things that do depend on the height. Here's the new table 601 out of the 2021 IBC. Here's the new construction types right here under type 4. In the 2018 IBC, you see, types 1, 2, 3, 4, and all you see under 4 is HT. Now you've got these new ones, new columns. The principle here to mark with this table, and by the way, this is the table, of course, that sets the fire resistance for the building structure. It's not requiring fire resistance for purposes of exits, corridors, occupancy separations, nothing like that. This is the basic fire resistance of the structure itself, the walls, floors, and roofs. The committee said we want our new type 4B buildings, we want a category that performs in fire the same way a type 1B building performs. So they set their ratings. The first thing they did was they set the ratings the same. And this, of course, has some non-combustible protection required as well. And then they said, we want our 4A buildings to perform like a 1A building. So they set those ratings the same. So these are parallel, type 1A and 1B. For type 4C, which is exposed, you can have exposed mass timber, they said, let's make it rated mass timber, but since we're not going to require non-combustible protection, let's make the ratings the same as 4B. Let's make them conservative. So they did. So 4C, it's 2 hours throughout. And as a result of that, there are some additional stories allowed in the 4C height, we'll see. But the height in feet above grade was not increased above what's permitted for traditional type 4 heavy timber. And there's many reasons for that. Primarily, this is a lot of exposed mass timber. So the fire risk could be considered similar in terms of height and feet above grade to traditional heavy timber, even though it is more highly fire resistance rated. There's more mass to the timber. Okay. Now, this doesn't exactly match your PDF, so don't be alarmed, but I did insert the title for this table here. Those of you who got an earlier version of PDF, just says table 705.5 up there. Same slide, same table content. Just added the title back in, which was omitted for some reason, my mistake. And you might say, table 705.5, that doesn't ring a bell. That's because in the 2018 code, it's table 602 for exterior walls. So currently in your code, as most of you are well aware, you have two tables, or you have, well, when it comes to exterior walls, you have two tables that you have to worry about. Table 601 that we already looked at, and table 602. But that number has been changed. So this is the exterior wall table. Currently in the 2018 and previous editions, it's table 602 in chapter 6. Now it's in chapter 7 in the exterior wall section. It's a new number. The new construction types have been added in where they are appropriate, okay, for rating for exterior walls. You see according to occupancy group and according to fire separation distance, how close it is to the property line. Now, both tables deal with exterior walls, as you know. So what do? What if these conflict? This is what you do, and this is what the code requires you to do. You take them, for the exterior wall in question, you take the more restrictive fire resistance rating between the two tables. End of story for what the rating has to be. Just take the most restrictive. Now, some of you are questioning in your minds two different purposes of the table. They got to work together better than that and so forth. No, that's all it is, the more restrictive rating. However, there is one caveat, and that is if the exterior wall is 10 feet or less fire separation distance, then it has to be rated for fire exposure from both sides. And that applies to any wall, any occupancy, any fire resistance rating. If it's 10 feet or less to the property line, it has to be rated for exposure from both sides, a symmetrically rated, fire resistance rated exterior wall. Otherwise, it just has to be tested for exposure to fire from the inside. Where did I find that requirement? Well, that requirement's in section 705.5. It's not new, by the way. That's been in the current code. Now, going back to the new construction types, 4A, 4B, 4C again, there is a requirement that's specific to the exterior side of the exterior walls, all exterior walls. This slide sort of implies there's just one requirement. There's actually two, but the illustration helps illustrate the two. So first of all, for all three construction types, even type 4C, there can be no combustible materials on the exterior side of the exterior wall. No combustible insulation, no combustible siding, no combustible cladding on the exterior side of a mass timber exterior wall that is required to be one of these construction types based on the building size and so forth. Now, secondly, there is 40 minutes of non-combustible protection required against the mass timber on the exterior side. So that's the equivalent of one layer of type X 5/8 inch thick gypsum board on the exterior side. So Ray makes a comment in his portion of this presentation about some of the reasons for this requirement. And it has to do with the committee decided they never wanted a fire to be able to travel up to greater heights in a building by taking the route of the exterior side of the exterior wall. So this requirement applies to all these construction types. I'll give you an example now of a cross-section of a type 4A exterior wall. This is an exterior wall. So right off the bat, this is the exterior side. Got that 40 minutes of non-combustible protection on the exterior. On the interior, if this is a bearing wall, this has to be 3-hour rated. The table 601 tells us bearing walls in type 4A have to be 3-hour rated. We've said that it's required that 2/3 of that overall required fire resistance rating has to be achieved by the non-combustible protection. 2/3 is actually 120 minutes. 3 layers, the equivalent of 3 layers of 5/8 inch thick type X gypsum board over here. So it's a typical bearing wall in 4A. You can see how conservative this is in terms of fire resistance. And by the way, I mean, fire resistance for a mass timber wall that's solid timber is really quite different than a repetitive member assembly. When we did our first compartment fire tests with mass timber, AWC did it back in 2015. We did an exterior wall test and it was a 5-ply exterior wall. This just shows 3-ply. So it would have been like, let's see, 5 would have been like 7.5 inches thick or something. But anyway, we had 1 layer of type 5/8 inch X, type X gypsum on each side, and the wall achieved 3 hours fire resistance rating with just 1 layer. So the massiveness of the timber and the uniformity of the plane, you know, to support the gypsum, all that kind of stuff. Really, fire resistance for mass timber is pretty significantly greater than for frame assembly. Okay, now I'm going to transition into the heights and areas with a few more principles here, but I want to note that if you haven't seen our previous webinars, the new heights and areas are based on the fire research done by the Tallwood Ad Hoc Committee in a very innovative testing program. In addition to the other testing that had been performed already, the committee decided to do full-scale, multi-story residential type building and test it. And the performance objectives here were very conservative. They did not want the sprinklers to operate. So in the first 3 major tests, they did not allow any sprinklers to operate. They did not address the fire in any way. They let it burn itself out. They had a typical residential fuel load in the buildings. The testing program is fascinating, and you can see those videos on our website. And they were done at the Bureau of Alcohol, Tobacco, and Firearms. And I'm going to pull in a photo here. This is what the if you are not familiar with cross-laminated timber, here's a good picture of it. It makes solid timber walls, floors, and roofs. This is what the structure was that was tested, and the test. Let's see if I can. Whoops! I got to get out of this apparently. Let's see if I can do this. Yeah. So the test was performed in this test facility. You can see the scale of the testing here. If you haven't seen these photos already, they burned this one with an exposed ceiling already. They're replacing the CLT panel for another test. I just wanted to pull those photos on to give you a sense of, they let these fires burn out, and they wanted them to perform like type 1 buildings, and that's what they were testing for. So the protection, conservative as it is, we are going higher. At first blush, people think of wood building going up to 18 stories. They think it's not the same story as a typical wood building, and the testing has really supported that. So going up, here's a first requirement right off. Let's say you have a type 4A building, and this shows a schematic at 18 stories. Only certain use groups can go up to 18. But you have 1 inch of non-combustible material above the mass timber on the floor. And this also applies to type 4B buildings. Of course, we've already discussed the interior and the exterior covering. The reason the committee included the 1 inch on the mass timber floors was they had not tested anything nor seen any tests that were not done with floors that were protected with concrete. So they decided they needed to keep that as one of the requirements. Just looking again quickly here now at a type 4B wall section. The difference here between type 4 and B4A is this: you can have some exposed mass timber, and 4B is never required to be 3-hour rated. It's always 2 hours. So you have 2/3 of that is 80 minutes, which is 2 layers of 5/8 inch type X. These are supposed to be equally thick layers. The diagram doesn't make it look that way. But once again, 2/3 for 2 hours is 80 minutes. So you, little calculation here shows you how you can get the 80 minutes. Always the 1 layer on the exterior or the 40 minutes. And what about that unprotected section? How much can be unprotected? I'm going to show you a few pictures here about how much can be unprotected. But this is the actual code language. If you're not protecting the ceiling, some part of the ceiling, 20% of the floor area can be exposed on the ceiling. If you're not protecting the walls, an area equal to 40% of the floor area can be unprotected on a wall. And in the dwelling or in the fire area, it would be on all the walls together, not more than 40%. And then you can make a combination, but you have to use a formula that I'll explain in a moment. Now notice this wording: in any dwelling unit or fire area. For you code officials, the amount of exposed mass timber will be calculated, in comparison to the floor area of both. You have to check the dwelling unit and you have to check the fire area for that limit. Columns and beams that are not integral to a wall or ceiling, the surface area of them does not have to be considered in this calculation. However, don't be confused. If it's part of the primary structural frame or it's a column, structural column, it still may have to be protected with that 2/3 of the required fire resistance rating for the element. And if it still has to meet the full rating, and if it's not integral, you can leave it exposed as long as it's still fully rated, but then you have to count that surface area into the amount of exposed area in the dwelling unit or the fire area. I hope I'm not being too confusing the way I'm describing it. But this is a test 2 of the Tallwood Ad Hoc Committee at the Bureau of Alcohol, Tobacco, and Firearms test facility. They left the ceiling exposed to simulate a type 4B construction simulation. Schematic might look like this. If you had an exposed area here, 20% of the floor area, that would be the area limit there. You could split that up into multiple smaller areas as long as it didn't exceed 20% of the floor area. For walls, the combined areas of these exposed walls couldn't exceed 40% of the floor area. And here, if you want to do both, here's that formula. It looks complicated, and I know you can't take the time to read through this probably. I'll just tell you this ratio right here. Let me get my highlighter back here. So this ratio right here is the actual amount of unprotected area on the ceiling over the allowable amount of unprotected area, the allowable area on the ceiling that could be unprotected. The actual unprotected area on the wall over the allowable unprotected area of the wall. And then you add those ratios, it has to equal 1 or be less than 1. And if this seems familiar to you, it's the same principle used for calculating allowable areas for mixed use occupancy buildings. So you have seen this kind of equation before. Okay. So here's the combination. These would have to fit into that formula. Actual exposed area over allowable and so forth. Actual over allowable for the wall. You add them up. And this is showing just an exposed ceiling panel next to a beam. That's a structural beam that it is covered, so it is integral to the ceiling, floor ceiling, and it would have to The area of this beam would have to be counted. The area of these columns would have to be counted in the calculation. This could be exposed without adding to the area of exposed walls, for instance. It could be exposed. Okay. And this beam, if it's exposed, it has its area, its surface area has to be added to the calculation for how much of the ceiling area could be exposed. By the way, these illustrations, along with the numbers for working this out, can be found in this manual that I told you about at the beginning. And this is showing an exposed beam, exposed column, and the area of the exposed column would not contribute to the area allowed for the exposed walls, but of the beam would have to be. And this schematic is just showing how these kind of limits might actually appear in a single story, in a multi-story, in a high-rise building. These are not floor openings. They're showing where there might be exposed mass timber, just for purposes of illustration. So if you have exposed ceiling areas and you also have exposed wall areas, there's one more requirement. It's about being separated by not less than 15 feet. So let me show you here. I'm going to skip that one. Let's go here. Wall, ceiling, 15 feet. If that doesn't meet 15 feet, got to move it over. What's the concern here? Well, in a fire scenario, if the sprinklers don't put it out or the sprinklers don't go off, you don't want the contents fire. This will obviously begin to burn, char, and may reflect off each other. We don't want them reflecting off each other. This will enable, when the contents are burned out, this will enable the combustion of the mass timber to be unsupported. It will put itself out. It will go out because it doesn't have enough fuel to keep going, and because it is mass timber. But there has to be some separation so they don't reflect off each other. That's the kind of thing they experimented with and tested in the full-scale testing. Okay, this shows 15 feet there. This shows you can measure it as the crow flies between two different wall surfaces. So let's talk about type 4C. And by the way, if you may have many questions as we go along, feel free to open up your chat box and chat them to Lori Cook, our Director of Education, who's going to be, we're going to have some time to address those questions at the end. But type 4C, the interior areas have no requirement for non-combustible protection. This is showing what looks like nail laminated timber assembly, and then glue lams for beams. It can be exposed in all interior areas, but there's a few features that cannot be exposed. The exterior side of exterior walls, as we've already said. The floors do not have to have that 1 inch, but they can have typical floor coverings. And by the way, even in the higher type 4 construction types, as long as they have that 1 inch of non-combustible material underneath the floor covering, it can be traditional floor coverings on top. You could have traditional wood floor coverings, for instance, on top of that non-combustible material, but the non-combustible material is protecting the mass timber structure beneath it, or it could be, conceived to serve that purpose. And then even in type 4C, in concealed spaces, the mass timber can't be exposed. So that's flipped a little bit. Your real fire hazard is in your interior areas. They can be exposed, mass timber can be exposed, but what the committee was concerned about was if fire does get into a concealed space in a fire scenario, that it would travel, through the concealed space. So there was no reason not to require it to be protected, the same protection as the rest of the structure, or in this case, of type 4C in terms of shafts. Why can the interior be exposed? Well, it's living area. It's viewable. We know where the fire is. We know how to address it. In almost every case, the sprinklers will address it, but if not, then there's the, it's visible. People will leave, the fire will burn. It won't be traveling through spaces of the building that can't be seen. It will need to be addressed in a type 4C building, but it's more manageable when it's confined to the interior areas and not left to go throughout the concealed spaces. And then shafts, a life safety feature, strong life safety feature, contain your exit stairs or your elevators, and both at least 40 minutes protection on each side. So a typical type 4C wall section, this is an exterior wall because it shows the 40 minutes on the exterior side. Okay. Okay, Marcy.
Absolutely. So mass timber shaft walls in type 4C construction must be protected by a minimum of how much non-combustible protection? None, fire resistance rated only, 25 minutes, 40 minutes, or 80 minutes. This one's a little bit split, but there is definitely one answer that's a forerunner.
Yeah, it might be a little tricky if you don't read the stem carefully. Now everybody's going back and reading the stem.
All right, so I've got 70% in 45 seconds. So let's close. So 56% say 40 minutes, 22% 80, and 17% none. So Paul, what do you say the right answer is?
Okay, it's 40 minutes. And let me just review quickly here. First of all, it's a shaft wall. We made a big deal that type 4C doesn't require non-combustible protection, but shaft walls do. And what is it? 40 minutes on both sides. Okay, so the key here was making sure you saw the shaft wall provision. The 80 minutes would be applicable to, well, let's see, would it be applicable? Wouldn't be applicable in, yeah. Think about this. Where would that be applicable? That may be applicable in concealed spaces. Let me think about that a little bit. But anyway, 40 minutes is the correct answer for shaft walls. And how about the rating? Still has to be 2 hours, okay? 2-hour rated walls. Okay, so the 40 minutes is not all you have. You've got the 2-hour rating, typically for shaft walls above 4 stories, right? 4 stories or above. Okay. Okay, just a little illustration here in the actual code text. The new principle, once again, is this floor, if it's 2 hours, the whole floor has to achieve a 2-hour rating. Then the secondary requirement, unique only to these construction types, is 2/3 of 2 hours has to be accomplished on the surface. So this would be 80 minutes here for the floor, if this is 2 hours, because 80 is 2/3 of 120 minutes. And the same for the beam. Now I've been talking about, there's a lot of words here. I'll just tell you what this is about. This is showing you that you don't have to use gypsum wallboard for the non-combustible protection. You can use any non-combustible material, and if you have some other material you want to use, test it. Test the assembly, the mass timber assembly without. Test one to be without the protection, and then test it with the protection. And the code provides a way for any non-combustible material in the typical fire resistance tests to demonstrate that it's contributing 2/3 of the fire resistance rating. If you don't want to do the test, you can use the prescriptive gypsum details that are provided for in that subsection there. And that subsection there will say, if you don't want to run the test, use these tables. So if your element is 1 hour rated, got to have 40 minutes. If it's 3 hour rated, got to have 120 minutes of fire resistance contributed by the non-combustible protection. And then it gives us another table that shows you a handy reference for how many minutes are typical gypsum wallboards given. And there's prescriptive provisions in the code for attaching the non-combustible protection. And for you code officials, this will be a plan review and inspection point, certainly, how the non-combustible protection is installed. You have minimum fastener sizes. You have minimum staggering of joints in each layer of the gypsum. You have a detail that requires the wall gypsum board to always be supporting the ceiling gypsum board and not the other way around. So this will be an inspection detail to make sure that the gypsum has full effect, for protecting the mass timber. And the same prescriptive details for nailing and so forth for the gypsum on the exterior. Same thing, yep. Just to show you have code provisions for that as well. And finally, there are some relatively minor subtle requirements for occupancy separations and incidental use areas. And what all these words are saying is simply this. If this is a required occupancy separation between group B and group R, and you're in a type B building where maybe you could have some exposed mass timber over here, what those provisions say is you can't have it exposed over here if it's a required rated occupancy separation or required rated incidental use separation. In that case, you of course still have to achieve the full rating that's required, but you also have to make sure you have at least a 1/2-inch gypsum board protection. It's a kind of, the code actually calls it a thermal barrier, but it's a bad term. It's not a thermal barrier, it's just non-combustible protection. And yes, I am criticizing the committee a little bit, and I may be wrong and all that, but I think we've all agreed through many discussions that thermal barriers are to protect foam plastic insulation, foam plastics in buildings. That's the way the code uses the term thermal barrier. This is not protecting anything hazardous. It's just more non-combustible protection, more fire resistance for the mass timber. Okay, so it's a minimum amount required. You still have to use the rating. Just be aware that that requirement is there. So now finally, we're going to actually step into what are the numbers that are the result of all this protection and research that's gone in. And I'll start by saying you use the exact same formulas for height and area that you already are using in Chapter 5. And you use the same tables. That is, if you're currently on the 2015 or later IBC. And so it looks like this. The new tables in Chapter 5, you use the same formulas that you did before and plug and chug. You go in and find your limits for height and feet above grade for your new construction types. These are new columns in Table 504.3. You can see that the heights in general are parallel, pretty much, not quite, to type 1B. Some of them are considerably less. One of the procedures of the committees was to go through and think about each occupancy and make some judgments on when they needed to be reduced through many discussions and votes and so forth. You'll notice that the allowable heights for type 4A are certainly not unlimited, as they are for 1A. But they do go up to considerably high for certain use groups, 270 feet. This is the highly protected, no exposed mass timber, highly rated use group from type 4 now. Certain occupancies, of course, don't go nearly that high. The height and grade above feet for type 4C is the same as traditional heavy timber, did not increase in height in feet above grade. It is rated for 2 hours, That's a considerable increase in rating over traditional heavy timber by at least 1 hour. But we do get some extra stories. Let's look at this. So this is table 504.4. Just shows part of the table here. So type 4B is somewhat parallel to the heights permitted for 1B. Type 4A, certainly not parallel at all, but limited. But up to, even for the assembly use groups, so that restaurants can be on the top of buildings and so forth, we got even up to 18 stories. Type use group B, 18 stories. Those are the significant changes for this new, well, it's just everything's changed. It's a new construction type altogether. Let's look at the ones for, so the hazardous use groups greatly reduced, as you can see. Institutional and I2 greatly reduced. How about group R? So just like B, up to 18 for the highly rated, highly protected mass timber. Drops down when any exposed mass timber, it drops down to 12 stories as a maximum for hotels and apartment buildings. These changes in the table down here are miscellaneous changes that are corrections to the code for certain construction types and occupancies groups, group S in the S group category. They're unrelated to the tall wood provisions. How about areas? First of all, keep in mind that since the 2015 edition of the code, table 506.2 is allowable area factor. So these figures in these boxes do not represent a realistic allowable area per story for any particular occupancy or construction type. They all have to be factored with those equations in chapter 5. So this was quite a little bit of a revision in the IBC for the 2015 edition. It does result in more accurate allowable areas per story and heights. By I say more accurate, I mean just against, it helps prevent mistakes when people make mistakes. The committee said, well, let's see, 4C is 2-hour rated, whereas HT is not rated, but generally considered by virtue of the heavy timber to be about 1 hour. Let's go up, let's give them a 25% increase in area per story. So that's what they did. They evaluated B as a two times increase in area per story, and then the heavily protected, highly rated type 4A, three times the allowable area per story of traditional heavy timber. You might say, what are these? Well, I'll move down here to group R's. We can look at those while we're doing this. So here's the allowable area per story, group R. Again, the factor. These all have to be factored. These do not reflect the allowable area per story of any particular building. Non-sprinklered 13R system, sprinklered 1-story, sprinklered multi-story. That's what these rows stand for. How can you have a non-sprinklered row? Well, all group R's do have to be sprinklered. So this is used only for existing buildings. And also, I might remind those of you who are used to using these formulas in chapter 5 that the NS value is used in those equations in chapter 5. So it's needed for those equations. And you can peruse these numbers at your leisure. They do result in good sized buildings, but keep in mind that there's also a total allowable building area, not just area per story, but building area that kicks in. So as these buildings get taller, they're not unlimited in area. So the area of the total building has to be limited to the area that is represented by the maximum single story area times 3. So as a building gets up to 18 stories, these allowable areas per story get smaller. Keep that in mind. But anyway, type 4A, a little summary table. For some occupancies up to 270 feet. Number of stories varies by occupancy. Fully protected mass timber. Sprinklers, yes. And we had the question in the morning, what are all these required to be sprinklered? Sprinkler requirements are the same. If it's a high-rise building, it's required to be sprinklered. If it's a group R, it's always required to be sprinklered. So you can have some mid-rise to low-rise and mid-rise group B, for instance, that may not be required to be sprinklered. But for the most part, when you get as soon as you hit 75 feet, an occupied floor level, 75 feet above the access for the fire department below, the code requires in Chapter 4 that the building be sprinklered. So anything high-rise has to be sprinklered. Same with mass timber. So the primary frame is 3 hours. The fire resistance contribution of the non-combustible protection is 120 minutes, very conservative. The floor framing, 2-hour rated. Stair towers once you're beyond 12 stories in type 4A, the stair towers are non-combustible. They cannot be mass timber. If the building doesn't exceed 12 stories, they can be protected mass timber. Floor toppings required. A summary table for type 4B as well. So you can kind of look this over at your leisure. Just tops out at 180, tops out at 12 stories for certain occupancies, not all. Partially exposed mass timber and those limits we discussed. Stair towers, up because it's up to 12 stories, can be mass timber, but must be protected with non-combustible materials. And floor topping, yes, type 4C, maximum height of 85 feet, same as traditional heavy timber. Fully exposed, except in concealed spaces, okay, protected. And shafts have to be protected mass timbers and shafts and so forth. So a summary slide here shows a relative, diagram comparing them. Each of these has a caption that shows the maximum allowable building area spread across, in this case, it would be 18 stories. This is a business occupancy. So average area per story is 54,000 in this case. Single story out of this could be greater, but you'd have to reduce the areas of the other stories and so forth. So for each here, same height and feet above grade for both 4C and 4HT. Okay, that was a lot in a very short time, although I did go over by a few minutes. So I'm gonna turn it over to Ray, maybe Marcy to Ray.
Thanks, Paul.
Hi, Ray.
Thanks for your presentation. I'll just share my screen. So, my name is Ray Obrocki. I'm the manager of Fire Service Relations for the American Wood Council. Prior to that, I was a Baltimore City firefighter for 23 years. I was the fire marshal for the city. I retired where I oversaw the fire marshal's office, fire code enforcement, and fire investigations. Then I retired the assistant fire chief, and I went to Rockville, Maryland, which is a little city outside of DC, where I was the chief building official for a period of time, and the fire marshal's office actually fell under the building department there. Then I went on to be the chief building inspector for Prince George's County, which is a large county suburb of DC, and now I'm with the Wood Council. So I tell you that just so you know who I am, and also because construction fire safety really does touch building and fire officials. Both are responsible for ensuring that these sites are safeguarded. So over the past several years, there have been several fires in buildings under construction. We've all seen them on the news. Many of these fires were in large structures of light frame wood members prior to the installation of active and passive fire protection systems. You see the multifamily mixed use. So these fires were at least trending up, at least in the minds of the Tall Wood Building Ad Hoc Committee. So they wanted to address fire safety during construction. Even though the law statistics apply to light frame construction and mass timber has an inherent fire resistance and structural integrity due to the mass, the size of the timber elements, the potential risk of fire in combustible construction was considered by the committee. And they came up with a couple provisions that apply only to mass timber. I'm going to actually go over all of the new provisions that cover mass timber. Some of the provisions apply to all construction, and some apply just to mass timber. I will distinguish which ones are which as we go through it. But the construction fire safety provisions put in by the TWB were standpipe requirements, water supply, non-combustible protection during construction. Paul talked about the finished product. I'm going to talk about the requirements during construction and exterior wall coverings. But mass timber inherently, because of the way it's built, there's less of a chance of a construction fire than other types of construction, because to put it in context of something you're probably familiar with, it's most like precast concrete construction. It's panelized construction. The panels are fabricated off-site. They're brought on-site and usually assembled fairly quickly. So there's not a lot of combustible building materials laying around. There's no waste or very little waste. So that in and of itself helps the issue. But the TWB added some. And the first provision, well, this is just a slide saying that the type 4A, type 4B, and type 4C construction designated to be greater than 6 stories above grade plane, you have to provide standpipes during construction in accordance with section 3313 of the ISC. This applies to all types of mass timber construction. So the standpipe requirement, where required, buildings must have standpipes. This is during construction. Not less than 1 standpipe shall be provided for use during construction, installed prior to the construction, exceeding 40 feet in height, located adjacent to stairwells, and stay within 1 floor of the highest floor of construction. So during construction, the standpipe is the most important fire protection feature prior to the sprinkler system coming online. The standpipe is the quickest, most efficient method to convey water to the upper floors of the structure. And minutes count when it comes to construction fires because they are so exposed. And for fire departments to have to drag hose lines all the way up or throw ladders and drag hose lines really takes a lot of time. And it's time that the fire service really doesn't have on construction site fires. So right out of the bat leads us to our fourth and final poll question. Marcy?
Yes, indeed. So here we go. In buildings required to have standpipes, they must be installed before the building construction exceeds what height? 1 story if combustible materials are on site, 18 feet, 40 feet, or 4 stories? Okay, I've got 30 seconds. I'm going to go ahead and close. All right, so 54% say 40 feet, 25% say 4 stories, 12% 1 story if combustible materials are on site, and 9% 18 feet. So Ray, what do you say is the right answer?
The right answer is 40 feet. 40 feet. So prior to 40 feet, you need, well, once you hit 40 feet, you need to have a standpipe that goes up with the building. And remember, just to repeat it, it has to be one floor below the floor of active construction and go up as the building goes up. Another requirement for mass timber buildings is a water supply for the fire department operations as approved by the fire code official and the fire chief, I should say, or the fire chief. So you have to have an approved water source by the fire department, approved by the fire department, as soon as combustible materials arrive on site. So new provisions of the 2021 IFC and IBC provide requirements for minimum water supply for fire flow and for standpipes during construction. While these new provisions were developed separate from the tall mast timber construction provisions, they are nonetheless important for these new construction types as well. And you'll see combustible materials arrive on site upon the commencement of vertical combustible construction and upon installation of the standpipe. These are the triggers. So prior to this, the code provided very little guidance on fire flow. It simply said an approved water source. It didn't even say approved by who. It just said approved water source. So this provision actually gives a minimum fire flow. So when combustible materials arrive on site, a minimum flow of 1,000 gallons per minute shall be provided. You have to have a fire hydrant within 500 feet of combustible building materials. So this gives a little bit of guidance. Now you can debate whether the amount of fire flow is going to be adequate, because I've seen building multifamily type 5 buildings catch fire and the fire department can throw anywhere from 5 to 10 to 25,000 gallons a minute. But before there was no guidance, now you at least have a starting place for it. They also considered separation from the property line when it comes to fire flow. They refine it a little bit. Then once again, this is not specific to tall mast timber, but it applies to mast timber. It applies to mast timber. It applies to type 3 and type 5 construction. And it is based on distance from the lot line and adjacent property, or a lot where you could otherwise build something. So the separations up to 30 feet require a minimum flow of 1,000 gallons a minute, or the entire fire flow required for a building when constructed, whatever is greater. A separation from 30 to 60 feet, a minimum of 1,000 gallons a minute, or 50% of the fire flow required for buildings for the building when it is complete, whatever is greater. And a separation over 60 feet, a water supply of 1,000 gallons a minute shall be provided. So I had said that the current base code provided little guidance with respect to water supply during construction. This simply just says where a standpipe is required, a minimum flow of 500 gallons a minute shall be provided. Yeah, so I mean, the construction fires have just been a problem recently, and one of the issues with construction fires is that water supply infrastructure is not always complete prior to vertical construction of the building, and the lack of a reliable and sufficient water supply has contributed to significant fire loss during construction site fires. The fire service can't suppress a fire of any significant size without a reliable water supply. They also have a provision in the IFC for non-combustible protection. This is the stuff that Paul talked about. So where a building exceeds 6 stories, at least one layer of non-combustible protection, where required by section 602.4 of the IBC, shall be installed on all building elements more than 4 levels below the floor of active mass timber construction. So note the word where required, because in type 4C construction, you're not required to cover the mass timber on the inside. Now, to say that all the mass timber is exposed on type 4C construction isn't entirely true, because in bathrooms and in kitchens, you're going to have to cover the mass timber not for fire safety reasons, but for hygienic reasons. You have to still line shafts, and if there's barriers, they have to be covered, fire barriers rather. So there will be some, but anyway, this really just applies to type 4A and 4B as the building goes up, including mezzanines on the interior of the building. Here's just an illustration showing the required passive protection during construction. You can see how protection, represented as a gray color, is applied to the mass timber on all the levels more than 4 stories below the floor of active construction. In other words, in this hypothetical building under construction, work would not be able to proceed on the 9th floor until the passive protection is applied as required to the mass timber on the 4th floor, as shown here in this figure. Only then can construction proceed to the 9th floor. Now, this is really based on what was done up in Vancouver, British Columbia. The 18-story Brock Commons mass timber hybrid structure incorporated techniques of adding non-combustible protection on floors below active construction level. Protection included 1 layer of type X gypsum board onto the underside of the CLT panels. So Paul talked a little bit about exterior wall coverings. During the TWB study of tall wood buildings and their subsequent deliberations, the Grenfell Towers fire occurred. And this is not a picture of Grenfell Towers. Grenfell Towers was a type 1 building. And in 2017, a fire occurred. It killed 72 people. The fire started on the 4th floor and quickly spread outside the building to the exterior cladding, which on the outside of the exterior cladding was non-combustible, but in between the two, I believe, aluminum non-combustible panels was an air gap and flammable foam insulation. So the fire burned on the exterior of the 24-story building. Hence, the TWB committee was mindful to protect the exterior of the building with a non-combustible cladding as the building is erected. So I just want to emphasize again, Grenfell Towers was not a mass timber building. It was a type 1 building. They'd had aftermarket, I guess you could say, cladding put on or replaced for aesthetic reasons. The other problem with the building is it only had 1 center stairwell, only 1 way out. Another problem is it wasn't sprinklered. So in a mass timber building, you're going to have sprinklers, you're going to have non-combustible exterior wall coverings, and you're going to have more than 1 way down and out the building. So these exterior wall coverings are required to go up with the building. So where a building exceeds 6 stories above grade plane, the required exterior wall covering shall be installed on floor levels more than 4 floors below active mass timber construction. And this would apply to A, B, and C, because C is still required. Even though they don't have to protect all of the mass timber inside, they do have to protect it, and it has to be non-combustible on the exterior side of the exterior wall. And just note that the term exterior wall covering is a defined term in the International Building Code. So non-combustible protection, heights and areas, construction, fire safety, and now we're at the home stretch, owner's responsibility. I think this is a really, really good provision they put in. And the reason they put this in to the code, well, let me read you what the code says. It says the owner shall maintain an inventory of all required fire-resistant rated construction. Okay. It has to be visually inspected annually and maintained. Okay. The International Fire Code had items for which the owner is responsible, the non-combustible protection and other requirements that are required in Type 4A and Type 4B construction. Construction materials currently required for buildings of similar heights and areas will not contribute to the fuel load in the manner that mass timber could. As such, tall mass timber buildings are required to include specific active and passive fire protection features to protect the occupants and structure from fire. As Paul told you, the code provision requires a specified thickness of gypsum board or its equivalent for walls and ceilings in mass timber buildings of Type A and Type B construction, except for limited amounts permitted in Type 4B to be exposed. The allowable heights and areas proposed are based on additional passive protection. As such, you need a methodology to ensure that this passive protection remains in place. So basically, what was contemplated was they were afraid that, let's say we have an 18-story apartment building or condo buildings, probably a better example, where all the mass timber is required to be covered with 3 layers of gypboard. But I take over and I say, or I buy a condo and it's a lot of money, and I say, you know what? I don't like all this drywall. I want to see some of the mass timber. I want to expose it because I like the way it looks and it's aesthetically pleasing. So the TWB was afraid that people, once the building got commissioned, or even the building management, would say, okay, take all that gypboard down. We want to expose it in the lobby or expose it here or there. So the owner is responsible for keeping a inspection reports that certify that the mass timber is covered, all the passive protection is in place and remains in place. Now, sometimes I hear people say, well, a man's home is his castle, and how can building management get into these apartments or get into these condos or get into these office spaces to ensure that they don't own it? I assure you, I actually have a condo, and there are agreements built into the condo agreement you sign when you buy it that allows for inspection. You know, you have to give notice, but you can build it into the lease agreement or the condo association agreement that would allow a third party or building management to come in just to make sure all the mass timber is in place. And I think it's really important. I wish it was for all buildings, not just mass timber buildings, because when I was a fire marshal in Baltimore City, we got into some high rises, and it was amazing the changes that building management made. We had one that we hadn't been in for years. It was an older high rise that wasn't required to have any fire permits at the time. And we got in there and found that they had taken the building fire pump and replaced it with a marine boat pump. I guess the old pump went bad, and they just found another pump, and it has nothing to do with mass timber. I'm just trying to illustrate how building management can do some screwy things once we're not looking anymore, or once they get their C of O. So that was what this was put in for. And what else happens after the building gets a C of O? You know, Verizon comes in, Xfinity comes in, and they start making Swiss cheese out of the draft stopping or the fire blocking. So this would ensure that none of that happens. And like I said, I wish it would apply to all. Okay, now this is not specific to mass timber. This is the daily fire safety inspection. This is not something that the jurisdiction of the AHJ does. This is an internal inspection where the site safety director, that's a new term in the 2021 edition of the IFC. It used to be called the Fire Prevention Program Manager, but they changed the language to site safety director, shall conduct or make sure it's conducting daily fire safety and like self-inspections on the exterior and the interior of the construction site and the subject building. The results of each inspection shall be documented and maintained on site until a certificate of occupancy is issued, and it should be made immediately available to the fire code official upon request. If they ask, and on the third time they've asked, the people on site cannot produce it, the fire department will have the legal authority to issue a stop work order, which in a lot of jurisdictions is groundbreaking, because you just don't see fire marshals' offices issuing stop work orders traditionally around the country. It's usually a building department function. And the fact that they have to do this every day until their C of O is issued is important. It really just builds in accountability on the part of the building owner and management and the general contractor, where it never existed before. And very quickly, before I open it up to questions, I just wanted to show you some of the areas of hot work, the temporary heating. This is what is listed in the code that has to be accounted for or inspected daily. And if you read NFPA's report on construction fires that came out in February, you would notice that this list is very similar to their list of common causes of construction fires. The other big change that I also think is impactful is that the site safety plan that is required by the code for all construction sites has to be submitted and approved before the building permit can be issued, before it can be issued. I think that's really groundbreaking because entities never had to submit a site safety plan, or like I said, it used to be called a fire prevention program plan, or a fire prevention plan. They never had to submit it to get a building permit. So consequently, once they get their building permit, we would have to run around and harass them to get it in. And because fire departments can't issue stop work orders generally, they would a lot of times drag their feet, if not flat out ignore us. So, you know, once you hold that building permit over their head, they will jump through hoop after hoop after hoop to get that building permit. But once they get that building permit and they can put a shovel in the dirt and they can start building, good luck, because they are so focused on construction, they could care less about a plan to submit. So anyway, this concludes the 2021 IBC Tall Mass Timber Height and Area and Construction Fire Safety webinar. I would open up to questions now. Could turn it over to Marcy or Lori.
Yeah, this is Lori. We'll do a little bit of Q&A, and then we will close things out. All right. We've had some great questions come in. Thanks everybody for your questions. One question, and this one is probably more for Paul, but Ray, feel free to jump in. It's asking about penetration protection. So if we have things, you know, like HVAC penetrations going through our assemblies, what do we have to take any sort of special precautions on these penetrations?
Well, all the provisions that apply to buildings, high-rise buildings right now, when it comes to penetrations, through penetrations, they all still apply to mass timber. There's nothing that is over and above what's already required by the code in regards to HVAC penetrations. When you agree, Paul?
Yeah, I just add, yeah, Jerry's exactly right. In my opinion, the same provisions for through penetration fire stop systems. You know, there's going to be some listings now that apply to mass timber as manufacturers get their listings and their tests, but all those same, there's been no alteration to any of that requirements for penetrations and their protection.
Great. Okay, we had a question come in about the water supply. Ray, I know you were talking about this. If we have a fire department connection, or do we need a hydrant at the building? Can you go over, I think you may have touched on it a bit, but what is, when we say a water supply is required, what do we mean?
Well, you have to have an FDC, a fire department connection, as part of the standpipe system. So that's going to be required no matter what, but it has nothing to do with actual water supply. No, you're supposed to have a main come in and supply at least one hydrant. That hydrant has to be 500 feet from combustible materials. So then that would probably make you have more than one hydrant if it's a large area building. But it has to be at least one on site 500 feet from combustible materials, and it has to flow 1,000 gallons a minute.
All right, great. Question for both of you regarding spray-on coatings or intumescent coatings for fire protection. Is that allowed? Would it be something that we have tests for, or how would people, if they wanted to try to use an intumescent coating, what kind of steps would they need to take to proceed?
I'll start, Ray, if it's all right. The provisions in the new code say have your product has to qualify as non-combustible, and you have to have it tested. You test the mass timber without it and then with it, and you provide the test report to the code official, and it can be approved for use as non-combustible protection for mass timber. Some departments may require it to, since the code also has prescriptive alternatives and doesn't exactly mention perhaps a new method, a spray on, an intumescent, or whatever it is that's non-combustible protection that's not gypsum. Some departments would require you to, could approve that through the alternative materials and methods section of the code, 104.11. I don't think that's absolutely required since the code itself provides a performance test, the ASTM E119 test to show the contribution for the new product, protecting the mass timber. So anyway, tests would be involved. It can be accepted, might have to be accepted through section 104.11, which is alternate materials and methods.
All right, great. All right, we're at about a